All right, we are going to spend a little bit of time just going over these limiting reagent or reactant calculations. We're going to work to find which one is a limiting reactant when we're given mass of each reactant. We're then going to work on determining the theoretical yield and then also a very common calculation of how much of the excess reactant is left over. So this little part is just from our books. It just gives you a definition of what we're explanation of what we're working on. One reactant, if we're given mass of each, is going to usually run out first, and it limits how much of the yield of the product that we can make. That's the limiting reagent or limiting reactant. The other one is one that would then be an excess. You have more than you need, and you'll have some left over that won't end up reacting. So we're simply just going to be applying our stoichiometry calculations to this and just using it for the purpose of analyzing kind of how much product we can make and how much is left over in a container. So you always need a balanced chemical equation for this. And this first one, it's saying that we are using 100 grams of calcium carbonate and 45 grams of iron 3 phosphate. So before, when we did stoichiometry problems, we only had one reactant that we had to deal with. So the other one was always told that it was in excess. So you could always start with this one reactant. In this one, and going forward, anytime you have masses of two reactants, that's going to be a limiting reagent question because we're going to have to figure out which one of those is actually going to help us determine the mass of our product. So we need to do a calculation to analyze both of these. Now, there are different ways that you can go about these calculations. I always do it where we're going to use each reactant. We're going to see how much of the product it can make. And then I just find that students, when they see that data, have an easier time kind of relating that back to determining which ones are limiting. So for this question here, we're going to have a calculation with our CaCO3, calcium carbonate, and we're going to do a separate calculation for our iron 3 phosphate. Okay, so with calcium carbonate, I'm going to work through this one first. I have 100 grams of it. And then its molar mass, which you would add up, and this is based on the AP reference tables, for calcium carbonate is 100.09, and that is 1 mole of CaCO3. Okay, then here we're going to use those mole ratios because I want to know how many moles of this calcium carbonate how much of our product are we going to make. So this is where we're going to use our coefficients. So we have our calcium carbonate, and based on the formula, that's 3 moles of CaCO3. And this is where labeling, again, becomes helpful. Now, I could pick either one of these products. Okay, as I look down here, it's asking about calcium phosphate, so I'm just going to use that to pick which one I'm going to proceed with. So that means then if I'm going to use calcium phosphate, it would be producing 1 mole of the Ca3PO42 from the calcium carbonate. Now, you'll see in my answer keys, I keep going to grams. Some students feel like that's more the work than maybe you need to do, so I'll stop it here at moles, but you'll see that on my answer key. But I always go through this step of it because I want to know how much of that product, or else you can kind of run into some errors along the way. So when you solve for that and you keep, in this case, to the 4 sig figs that you started with, I'm going to get 0.3330 moles of our calcium phosphate produced. Okay, then I'm going to go through the same process with the iron 3 phosphate. So I'm starting this one with 45 grams. Okay, the molar mass of iron 3 phosphate is 150.82, and that's for 1 mole of FePO4. And just remember again, these two things have to be equal to each other. If this is the molar mass that I'm getting from the periodic table, I always set that equal to 1 mole of it. The next step here, again, is that mole to mole ratio. Both of these have to come from my balance equation. In this case, I'm doing iron 3 phosphate. So for every 2 moles of FePO4, that's going to produce that 1 mole of the Ca3PO4 too. Okay, when I go ahead and plug that into my calculator around to the 3 sig figs that I started this one with, I get 0.149 mole of Ca3PO42. All right, so that just gives us information. Okay, you actually have to use this to then rationalize, well, which one's the limiting? So this is saying that with that 100 grams of calcium carbonate, I can make about 0.3 moles of calcium phosphate. If I have 45 grams of iron 3 phosphate, I can make about 0.15 moles of calcium phosphate. And I'm just rounding off here for discussion. You need to think about the fact that if iron 3 phosphate can only make this amount of moles, that means that it's then completely consumed, and then there's no more that the calcium carbonate can react with. So the lower amount tells you which one is your limiting. So what this tells me is that FePO4 is the limiting reactant. Okay, that means that I can only make that amount. Then FePO4 runs out, and I can't actually produce this amount from the calcium carbonate. Okay, so as we move forward on our next set of calculations, what is the theoretical yield? We're always going to start with the limiting, and it's going to be the same thing when we do part C on this. Okay, the limiting is going to help us determine how everything else is involved with this calculation. So we're going to start with, and I'm just going to write this all out. Some students may just take this answer. If you do that, please make sure you use the value in your calculator so that you're not rounding off too soon. So I'm going to start with my limiting. Okay, and this is 45 grams of FePO4. Okay, that is going to determine how many grams of the calcium phosphate can be formed. So this is going to be very similar to what we have above. So I have the molar mass of FePO4, which is equal to 1 mole of it. I'm going to use their mole relationship. So for every 2 moles of FePO4, I make 1 mole of Ca3PO4, 2. Okay, in this last step, I'm just going to use the molar mass of that product that I'm looking for. So just remember, when I'm using molar mass, which when you add it up is 310.18 grams of that Ca3PO4, 2. Okay, that is always then equivalent to 1 mole of it. Okay, so I'm going with grams of my limiting. This is going to help me determine grams of my product. And then keeping to the 3 sig figs, you'll get 46.3 grams. And that's the calcium phosphate. Okay, now one little thing that will come up when we go to do percent yield is this is always the theoretical yield. Okay, that's theoretically that if I have 45 grams of my iron 3 phosphate, that's how much I should make based off of just the stoichiometry. So that's the theoretical yield of that calcium phosphate. Okay. The last little part here that's a super common question is, well, you know, FePO4 is completely consumed. How much of the other reagent or reactant is left over? So remember, how much is left over is going to be determined by how much the limiting reacted with. So just like in B, I'm going to start this with my limiting. So I'm going to start this with 55.0 of my iron 3 phosphate. Okay, the first part of this is going to be the same. I'm just going to get it into moles, and then I will use that to relate it to my other reactant. Okay, using that balance equation, for every 2 moles of iron 3 phosphate, it's going to react with 3 moles of the calcium carbonate. So again, that's going to be 2 mole of our iron 3 phosphate. Okay, this is where labeling comes in to make sure you get the 2 in the denominator, and that's equivalent to 3 mole of the CaCO3. Okay, I want to know how many grams are involved with this. So I'm going to use the molar mass, so I have to make sure I'm filling this in as 1 mole, and that's equivalent to its molar mass, which we calculated up in letter A, which is 100.09 grams of our CO3. All right, when you go and plug that all in, and keeping with the 3 sig figs that we started with here, I'm going to get an answer of 44.8 grams of CaCO3. And then this is important, and this is what you need to think about every time you do these so that you don't make probably the most common mistake. What this means is 45 grams of iron phosphate reacted with 44.8 grams. So the big thing with this number is this is how much was actually consumed in the reaction to make the product. Okay, you cannot stop here because it wants to know, well, how much is actually left over? So this is where we're going to go one more step, where we're going to write down the amount that we started with. So 100.0 grams. This was the starting amount. Okay, minus how much was consumed. So this is how much was consumed by the reaction, which was determined by our limiting. And then when we subtract those and go by place value, which will be to the 10th spot, you will get 55.2 grams, and that is how much was actually then left over. That had nothing to react with once the limonene was consumed. Okay, so those are like the big calculations to start off limiting reagents with. I'll post a couple other videos to help you as well.